Hi everyone, in today's lesson we're going to review Venn diagrams. So let's talk through an example. Students were surveyed in regarding their enrollment in Algebra 2 and Chemistry. The results are given in the diagram below. So Venn diagram's already been given to you. We just need to answer the questions. How many students are enrolled in Algebra 2? So the way Venn diagrams work is anybody inside this entire circle would be enrolled in Algebra 2. So what you're going to want to do is simply add up 250 plus 75. And when you do that, you will get 325. So I'm just going to write down the numbers so you have it. I suggest you do the same. So 250 plus 75 will equal 325. So if you want to figure out how many people are enrolled in one subject, you just have to add up everything that's in this circle. Now, how about example two? How many students are enrolled in chemistry? Well, chemistry would be everything that's inside this entire chemistry circle. So what we're going to do here is we're going to add 75 plus 290. And that will give us 365. So again, there's 365 students that are enrolled in chemistry. 290 here and 75 here. Everything that's inside this circle. So now you might have been wondering, what's the difference between the 250, the 75, and the 290? Well, here's looking at example 3 and 4. How many students are enrolled in Algebra 2, but not chemistry? So in order to answer this question, we have to really dive into this Algebra 2 circle. So do you see how within the Algebra 2, there's 250 and the 75? The 250 is actually the answer to this question. The 250 students are the students that are enrolled in Algebra 2, but not in chemistry, because this 75 is unique. This 75 is in the intersection of these two sets or the two Venn diagrams. And as I'm sure you've learned from Venn diagrams that you've made in the past, the 75 is what's in both. So the 250 is in Algebra 2 only. The 75 is what's in both. And then if we just keep going, we might as well. The 290 over here, I'll actually use the same color as before. 290 is going to be what the amount of people that are in chemistry only. So let's see if that helps us answer the questions. So how many students are in Algebra 2 but not chemistry? That's this 250. How many students are enrolled in chemistry but not Algebra 2? That would be this 290. And then how many students are not enrolled in Algebra 2? All right, that one's a little different. So not enrolled. So that means everything but this circle. So all of these people in here are enrolled in Algebra 2, the 250 and the 75. So the 290 are the people that are in chem only, and this 885, that's new. This is outside both of the circles. So actually, this 885 is neither. These are the amount of students that aren't enrolled in chemistry or Algebra 2. So if I answer this question, how many students are not enrolled in algebra? It's everything that's not in this circle. So the 290 plus the 885. So we can go ahead and do that. So 290 plus 885. Now if you add those together, you should get 1,175. Okay, similarly, how many students are not enrolled in chemistry? So if this is the chem only area, this is both, everything in this circle is chemistry. So what's not enrolled in chemistry is everything not in this circle. So the 250 and the 885. So 250 plus 885, and that will give me 1,135. And then number 7, how many students are enrolled in Algebra 2 and chemistry? This, my friends, is the intersection. And the intersection of these two sets was 75. So I'll show you up here. Both chemistry and Algebra 2, that's the intersection, so 75. And then how many students are not enrolled in either Algebra 2 or chemistry? So who's not involved in anything? I think we answered that before, would be this 885. That's the neither. And then last but not least is how many students were surveyed in total? So we have to go back up to the top here. So 250 plus 75 plus 290 plus the neither on the outside, all of these added together will give us our grand total. So if you do that, let's write it out. You will have 1500 plus, well, not 1500, excuse me, that's the answer. 250 plus 75 plus 290 plus 885. That gives you 1500. So in order to find the total, we have to add up all of the spaces. Add up all. Right. Let's try another example now. So in example number 2, now I want to ask you to find the probabilities this time. So I've got students are surveyed about if they like to play soccer, baseball, or neither sport. So let event A be the event that students play soccer and event B that the students play baseball. So we'll call this event A and we'll call this event B. So we want to calculate the exact probabilities. So remember, for probability, we need a fraction, exact meaning fraction. So theoretically, we need a part over a whole in order to answer that, right? That's how we get a fraction. So the whole we need to figure out. What are the total number of people that were surveyed here? And the way that we get that is we add up all of the pieces. So 295, 175, and 330. So if you add those all together, you should get 800. So that will be my total out of everything. So I want the probability of event A. So what I'm asking there is I want you to tell me all of the people that are in circle A. So the probability that a person is randomly selected and they like soccer or they play soccer. So what we need to do is add up everything in the A total. So we have 200 plus 95. That will give me 295, but we need to divide that by the grand total of 800. So a probability, like we said, is a part over a whole. The whole we know is 800. The part is the 295, the 200 plus the 95. Now, I'm sure we can simplify this fraction, but we don't need to for simplistic purposes. Let's just leave it like this. Okay, next, the probability of event B. So what is the probability that a student plays baseball? So again, we need to look at the baseball circle, and we need to add up all of the amount of people that are in there. So we've got 95 plus 175. And when you do that, you get 270. And we need to divide that by the total of 800, part over a whole. Okay, next, I would like the probability of A complement. That symbol, I'm not sure if we spoke about it or not, this little dash here means complement. And complement means what's not in the given set. So in this case, what's not in set A. So complement. So I want the probability that a student does not play soccer, right? If A is that they play soccer and the complement symbol means not, it's those that do not play soccer. So we can't use the 95 because those people play both. We can't use the 200 because that's only soccer. So it's either going to be the 175 or the 330. The 175 is baseball only, and the 330 is neither. So we need to do 175 plus 330, and that'll give us 505. And we need to divide that by the grand total yet again, which is 800. So the next one, what is the probability of B complement? So that just means what is the probability that a student does not play baseball? So we can't use this or this because that's inside the baseball circle. So 200 plus 330. So 200 plus 330 is going to give me 530. And we need to divide that by 800. Okay, Next, I want to find the probability of A and B. Remember the symbol, that upside down U looks like an A, kind of means and. So what is the probability that somebody participates in soccer and plays baseball? That would be my intersection. The intersection there is 95. So 95 out of 800. You can say and is another way of saying the intersection. Okay. Next, what is the probability of A, U, B? That's the union. U stands for union, which also means or. So the probability of A or B. So we have a formula for this that we could use, and then I'll show you another way, but it's the probability of A plus the probability of B minus the probability of A and B. This is the formula we spoke about the other day. So the probability of A, we actually know here, is 295 out of 800. Then we have the probability of B, which we have here, 270 out of 800. And then we have the probability of A and B, which is down here, which is 95 out of 800. So all we would have to do is just add these fractions together. And if you do that, you actually get 470 out of 800. Now, there's a quicker way to know or. So remember how we showed you that the intersection, number 5, is where the two circles intersect, right? That's my intersection. Visually, the or is both of these circles and the shaded region between them. So in this particular case, you had all of this area here. Everything in both of these circles is the or. So really all you had to do was simply add 295 and 175. Let's see that it's the same. So we'll actually take our 200, our 95, and our 175. So let's check it out. 200 plus 95 plus 175, that definitely gives you 470. And since we want the probability, we have to divide it out by the 800. So honestly, all you really need to know is that the and is the intersection and the or is all of the elements inside both of the circles. So feel free to write these down and we'll go over them more in class tomorrow. All right, have a good night.